Okay, so in this video, I'm going to show you how to solve for the question lesson 1.2, 5 part B. So look at this question. So this is from the question, the sequence from the question. As you can see here, it is 5, 8, 13, and 20, right? And this sequence is neither arithmetic nor the geometry sequence, right? So let's check out the difference between the terms. As you can see, from 5 to 8 is at 3, right? But from 8 to 13 is at 5. From 13 to 20 is at 7. So as you can see, the difference is not the same. So we cannot consider this as the common difference. That means this actually is not the arithmetic sequence. Okay, but you notice something. What's that something? You see, these differences can form another sequence, right? This is like actually is a arithmetic sequence. Is a arithmetic sequence, right? Why? Because as you can see, from 3 to 5, you got a difference of 2, right? From 5 to 7, you have the difference of 2 as well. So we have the common difference for this sequence, and this is what we call the arithmetic sequence. So if you meet this kind of question, actually you should know about what this is how we call the sum of the arithmetic. Okay, sum of the arithmetic sequence. Okay, here you go. Here is the sum of the arithmetic sequence. What do you mean by this sum of the arithmetic sequence? Is that is the total of the number of the system. Let's say you see this first term. So what will be the sum of the first term? First term only one term, right? You don't need to add any other terms. So itself, right? So itself is the sum, is the total, right? So it's 3. How about if you add the first term and the second term? And this will be 8, right? So this 8 is the sum of the first 2 terms. Okay? How about the 7? Okay, if you add all of these 3 terms, you get 15. So 15 is the sum of the first 3 terms, right? This is the sum of the first 3 terms. Okay, so you can represent all of these sum of the terms. Yes, the sum here represented with S1, S2, and S3. Okay, we use this symbol Sn. Okay, so 3 is S1, 8 is represented by S2, so 15 is represented by S3. Okay, so how about this one, Tn? This one you also can represent it by T1, T2, T3, and T4. This is number of term, this is number of sum. Number of sum, number of term. Okay? Number of sum, number of term. So now I want you to focus, okay, I want you to focus on the T1, the T2, and the S1. So what is the relationship between the T1, T2, and S1? You see, T1 is 5, right? T2 is 8. S1 actually is 3. So what is the relation between 5, 3, and 8? How do you get 8 actually? You get 8 is from 5 plus 3, right? Like this one. You get 8 from 5 plus 3. And this is actually can be represented using the symbol, okay? The letter T2, 8 is T2, and 5 is T1, 3 is what? S1, right? This one, S1. Okay, so now I want you to focus on the second case. This is the first case. How about the second case? How do you get 13? Okay, how do you get 13? Using the T1 and the S2 and the T3. How do you relate the T1, S2, and T3? You see, S2 is 8, it's not 5. Be careful. S2, what I mean S2 here is 8. So how do you relate the 5, the 8, and 13? Actually, this 13 is come from 5 plus 8, right? 13 is come from 5 plus 8. And as you can see here, 13 is T3, right? 13 is T3. Your 5 is T1, always T1, right? So what is your 8? 8 is S2. S2. So this is the second case. How about the third case? How do you get 20 from 5 and 15? How do you relate the T4, T1, and S3? Here you go. 20, actually you get this 20 from 5 plus 15, right? This 20 equal to 5 plus 15. And 20 is represented by T4. And 5 is always T1. 15 is S3. So here is the pattern. Do you see the pattern? I want you to focus on T2, S1, the T2 and S1, T3, S2, T4, S3. These T1, they are all the same, right? They're always the same. In each cases, they're all the same, right? They keep the T1 the same. But the only difference is T2 and T2 and S1. As you can see, the number of terms is always 1 less than the number of term. Number of sum is always 1 less than the T2, right? You see, the number of sum always 1 less than the term. You see, if 2, this must be 1. You see, if 3, this must be 2. If this is 4, this must be 3. So here we have our pattern. That's this one. Tn will be equal to T1. T1 we always keep the T1, right? But this will be Sn minus 1, right? 1 less than the Tn. Now we get this pattern. This very important equation, okay, for us to derive the formula for Tn. Okay, now you get this one, right? So given that this one I already talked to you, okay, in the tutorial class. I already mentioned to you that you have to know this formula. Okay, you have to know this formula. This is some of the arithmetic sequence, some of the terms. Okay, some of the terms. Okay, so this is the formula. Okay, what do you mean by this A? A is the first term. Where is the arithmetic sequence? Here is the arithmetic sequence, not this one, but this one. This is the arithmetic sequence. The first term is 3. D is the common difference. The common difference is 2, right? You see, 3 plus 2 you get 5. 5 plus 2 again you get 7. So 2 is the common difference. So 2 is the common difference. D is the 2. A is the 3. Yeah? Be careful. And now I want to focus this one, Sn. Okay, I want you to, because I want to change to Sn minus 1. Okay, I want Sn minus 1, not Sn, right? So I need to change this n subscript here, n, to become n minus 1. So you need to substitute the n to be n minus 1. That's why you get n minus 2 here, because you need to minus 1 again to get n minus 2. Okay, understand this one? Is n minus 1 minus 1, so that you get n minus 2. So this is n minus 1. This one replaced with n minus 1. So this is the formula for Sn minus 1. This is the formula for Sn minus 1. So after you know this formula, okay, you know this formula. Do you know this T1? Yes, you always know T1. T1 is 5. It's always 5. We don't change the T1, always 5. So now we try to derive it, okay? So we put this Tn equal to T1 plus Sn minus 1, right? So this Sn minus 1, okay, replaced by this expression here. And then you know T1 is 5, A is 3, as I mentioned just now. A is 3, D is 2, right? And you substitute this value into this equation. Then what you get? Yeah, when you substitute, okay, you substitute these 2 with 3, this D with 2. And when you do the expansion, you see, when you take this, okay, multiply with this one, you can cancel the 2, right? When you take this fraction again to times with these 2 factors, you can cancel the 2. So what do you remain? You remain this one, right? After cancel, 3 times n minus 1, and then this one times this one, you cancel the 2, become n minus 2 times n minus 1 times n minus 2. So from here you do the expansion here, you get 3n, and then this one minus 3, right? 3 times minus 1 is minus 3. This one become n squared, and then minus 3n, n minus 1 times minus 2, you get positive 2, right? Okay, so how can you simplify this one? 3n and minus 3n become 0, right? 5 minus 3, 2. 2 plus 2, 4. So what do you get here? This one, n squared, right? N squared, the n, the like terms of n is cancelled out, right? Cancel out. So only left 4, right? The constant 4. So 5 minus 3, 2 plus 2 is 4. So here is our formula. So by using the formula, actually you can find the number of n term, right? Any term. You can find any number of the terms. Okay, let's say you see if I want to find the first term, t1, let's say I use this formula. Let's say I find t1, you represent this with n equal to 1, n equal to 1. What you get? 1 square is 1, right? 1 plus 1, or 1 plus 4, you get 5. Yes, this is the first term. Okay, if you let the n become 2, this will become 2. 2 square is 4. 4 plus 4, you get 8. Yes, this is the second term, t2. How about t3? T square plus 4, 9 plus 4, 13. Yes, 13. How about t4? You know it, right? 4 square, 16 plus 4, 20. Of course, you can find out the fifth term, right? You can find out the fifth term by replacing this n with 5. Right? 5 square plus 4. 5 square is 25. 25 plus 4, 29. Right? The next term will be 29. Okay. So by actually, you don't need to prove all of this step. Actually, if you're smart enough, you can, by using your observation, you know that this is actually about square. It must something to do with the square. So normally we will start with thinking about n square, and then you try to relate n square. After I put this n square, what should I do? What should I do with this n square so that I can get 5? Let's say n is 1. So 1 square is 1, right? How to get 5 from 1? Maybe plus 4, right? And you try to test it. Is it correct for all all the terms here? You see, if let's say the second term is 2, 2 square is 4, right? Is it always plus 4 you get the next term? Yes. Okay, 4 plus 4 you get 8. That's why you can conclude that, oh yeah, it's true for every term. Then you find out that n squared plus 4 is the formula. If you're smart enough, okay, if you have the good observation, you can straightforward to get this formula. But not that easy, okay. And you also have to know that it's something to do with this n square. It must something to do with the n square. If you see this kind of sequence, you see the common differences are not the same, but the differences can be the arithmetic sequence. In this case, the formula for the Tn here must be related to the n square. It must be related to n square. Then you try to think how you play with this n square. Okay, maybe you need to plus 2n and then minus 1. Maybe you divide it by something. Don't know. You just need to play around. If you don't know how, you just need to derive it. You just like what I do here, derive all of this thing. Then you can get the formula. This one. Okay, so this is the proving. Okay, the solution for the question lesson 1.2 part 5b. Okay, that's all for this video.